We've made real progress. We've now completed the logic classes, and before we move on to the interface, which is where WPF plays its role, I'm going to try and explain the role of WPF in general programming, because up till now what we've done could have been done for any type of programming. We create classes that do our data and classes that manage our methods, and that could be for anything. I will be posting this presentation as a file that you can download, perhaps remember things through the slides rather than through what I say. But what I want to do is talk about WPF in the most general terms, about its structures and what it's made from, how it's made up. So we talk about effective development approaches, and there are many, and we talk about event-driven programming, procedural programming, object-oriented programming. We talk about systematic development, we talk about sequential development, we talk about all sorts of things, functional programming, all sorts of things. But I think the goal of most effective programming is to separate the concerns so that things that you do only do one job, the things that you make have a single purpose. So we call that separating concerns. And in the most common practices, in some way, all of these systems of programming will separate the interface layer, the logic layer, and the data layer. So before I go into detail about what they each do, have a look at this diagram for a few seconds. That's a kind of graphical overview of what we're talking about. Now sometimes these are called tiers, sometimes they're called layers. It kind of depends on which textbook you read. So let's talk about the data layer first. For our application, that's going to be a simple text file, and we use classes to access the data and the methods that return items and lists. So that gives us input into our application. We never actually store anything in our particular application. Now the logic layer that we've done and we've built already has the classes have methods that we need in order to do the work for us. For example, they manipulate strings or they calculate values for us. And a highly effective system of extendable architecture, so that if I create a new logic class, it doesn't affect the ones that are already there. Each class sits to do a single job and makes it really easy to extend when we need more classes. It also makes it very easy for maintenance, in that we can maintain each of these classes individually without affecting the rest of the classes that are in the application. Then we talk about the interface layer, and that's where WPF really sings. In our WPF structure, our architecture, each interface has its own layer file, and each one has its own logic layer file. So whenever I make a page or a screen, I'll have two files associated with it. It'll have a XAML file and a CS file, a C# file. The logic is implemented in the C#, and the interface layer is defined using a thing called markup. Now markup languages should make you think of HTML because they use a system of tagging, and the main advantage is that they use positioning which is relative and not absolute. So what I mean by that is it's almost like a percentage of this whole screen away from the left hand side and the top and the bottom and so forth, rather than saying that this text box's top left hand corner will be at position 50 by 19. It's much more relative than absolute, as it would be in a Cartesian system. So that makes it easier for us to create a responsive design. So our responsive design means that when we have a different option of interface, i.e. the size of this screen is going to be different from that screen, we can accommodate these differences much more effectively. It's written in a language called Extensible Application Markup Language, and I've highlighted the letters which make up its name, which is pronounced XAML. So what is a markup language? A markup language is interpreted by the interface at runtime, in the same way as HTML is interpreted by the browser at runtime when it's given data to process. So the layout is constructed from components, and the components live in containers. So maybe you should think about the div element in HTML5, and we put components inside this container so that we can display how our browser will look when it gets all the data it needs to show. But we'll do a lot more about this later. So let's talk about styles. Now, styles are a thing that we can write once and use many times because we process them centrally. Think about CSS. CSS means that you write a style for H1 once and you just use it again and again and again. You're guaranteed that it can be tested effectively, and it's going to give us a really strong application of a standard, so that a particular blue is always that same blue, and that a particular spacing is all that spacing, and so forth. And it certainly allows for us to reuse this style again and again. It also allows us to override that style when we need to, so that if a particular element of the style needs to be overwritten, because in this particular case it needs to be slightly different, we can easily do that. So let's talk about how these styles are actually used. We talked about the application of styles. Now we're talking about controls mostly in XAML, although there are other ways you can do styles. We're talking about the text box, the text block, the button, and so forth. And all of these controls have properties. For example, the background, the margin, the fonts, and the text box sizes, and so forth. So styles are applied to the properties of each control, and at container level, and at control level. So we say, for this particular type of control, we're going to make sure that we get the background color right and the margin right, and so forth. WPF is highly relevant. Microsoft is highly committed to it, made a really big statement to that effect last year. It's been around for a long time, so it's mature. It's been ported into the .NET Core, which is the future of all programming according to Microsoft. The .NET framework will die with its next release, and it's used in their own product development. For example, Visual Studio was developed in WPF. And the community have been asked to contribute into it, which is always a source of sort of hope that something is getting the backing of the whole of the community and the Microsoft organization. And the thinking process is linked to other types of things that we do in programming. For example, mobile development. We separate the markup language for the interface from the coding language that we use to manipulate data, and so forth. So it's really relevant and current. What I want to do now is just look back at that slide with the layers in it, just to reiterate what we're talking about once more so that it gets home. Remember that our goal is to separate the concerns. The concerning of display should be one thing. The concern of data should be another thing. And the concern of processing should be yet another thing. And we apply rules between these layers to make sure that this layer, the interface layer, only gets the things that it can easily display, and that the data layer only gets the things that it can easily manipulate with CRUD. And that's the rule of the business of logic layer that we already created.